Yes, please.
All right, so
Yes, please.
we are going to start with mathematics and symbolic logic today.
Okay.
That is the first class we are going to hold now. We'll see what it is all about and how it affects your exam. So let's go there. You complain that you have some issue with math, so God will help us. This one is not that hard, just some basic math. What we'll be dealing or doing in this unit, we'll be dealing with definitions, then some objectives of symbolic logic or logical reasoning. We'll talk about definition of basic logical terms like connective, tautology, and contradiction, and argument, algebra of propositions, and then conjunction, disjunction, negation, blah, 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 and so on and so forth. So let's see what we have here. Let's start here. I will be writing very soon, but I want us to read first. Mathematics is the science of numbers and shape. It can also be applied to some real life happening. Now, this statement you are seeing is very important because it's a question in the exam. It will tell
Okay.
you dash is the science of numbers and shape. Sometimes the question ends here, sometimes you complete it like this. But in any case, you should know that what they're asking you is mathematics. The mathematics is having S there before it completes. So mathematics is the science of numbers. And that is what math is all about. Math is just scientifically dealing with numbers and then shape. And it can be applied to real life events. It's not only numbers that math can be used for. It can be used for the real day-to-day activities that you are doing. This your place of work, at home, anywhere you find yourself. Math is or can be applied. So that is first thing to note, the meaning of mathematics. Now, example includes arithmetic algebra using of symbols or letters. Now, symbol is a context. Also, in this context, is a letter that is made up of, made to represent a statement or an argument. Now, this is another thing. They may tell you that dash includes arithmetic algebra using of symbols or letters. That is mathematics. We're still talking of mathematics here. So, example, let P, we want to talk about how math is related to arithmetic algebra using symbols. For example, let's say P represents the statement, she is tall and beautiful, which means whenever I mention P, for instance, if I have informed you before that letter P means she is tall and beautiful, anytime I mention letter P to your earrings, the next thing that comes into your mind is what? She is tall and beautiful. Because we've already attributed the letter, which the letter now represents a symbol. It's not like a symbol that when we decode the symbol, the meaning it's going to give us is she is tall and beautiful. And letter Q represents the statement, she is intelligent. We have two things now. One symbol P is presenting a statement that says she is tall and beautiful. The other one is a symbol Q that represents the statement she is intelligent. Now, let's see what we want to do with this statement. Therefore, P and Q can be regarded as a statement, also meaning she is tall, beautiful, and intelligent. The connective and combines two things together when the two of them are true. This is what we are trying. Okay, we are digesting this thing. Now, this is logic. What you are going into now is logic. What we are trying to do, we are trying to take you serially, just starting from the simple ones and then introduce logic to you. If I should tell you that, let's say Omotayo is tall and beautiful, and it is true that she is, right? And I also tell you that Omotayo is also intelligent. If I'm to combine all of the pictures of Omotayo together, I can use the connective and. Is that also? I would just say she is tall, beautiful, and intelligent. But that is only possible. You can only use and to connect two things when the two of them are true. So and is only valid in this combination because Omotayo is truly tall, she's truly beautiful, and she's truly intelligent. Otherwise, and cannot work. You can't combine statements that are false. You can only use and to combine them together when all the statements are true about what you are talking about. That is number one. We are going somewhere. That is not where we are going. We are just trying to explain that. So in the exam, they used to ask it like this. They will say, let P be the statement, she is tall and beautiful, and the letter Q be the statement, she is intelligent. They will now say, therefore, P and Q is equals to dash. You see them in multiple choice question. That is objective. You should know that P and Q will be, she is tall, beautiful, and intelligent. You see the way it is arranged. It did not, when we added them together, when we say and P and Q, we did not say she is tall and beautiful and she is intelligent. No. We combine them together saying she is tall, beautiful, and intelligent. So that is the combination. And there is a connective that connects two statements or more statements together when each statement is true. Hence, logic is the science of reasoning or explaining events. This is another question in exam. Mathematics is the science of numbers and shape. Logic is the science of reasoning or explaining events. That is how cheap the exams used to come. It's not something hard, but if you don't know before that logic is the science of reasoning or explaining event, if you see it in the exam that say dash is the science of reasoning or explaining event, you will not know what to write there or what to pick as the answer. So, but because you've gone through it like this, you already know that the science of reasoning or explaining events is logic. And what it means is that when I'm saying that P means she is tall and beautiful, and Q means that she is intelligent, and I'm using a logic now to connect them together, and say P and Q, all I'm just saying is that when I say P and Q, we're already talking about logic. And what P and Q is going to do is explain the two statements together about, let's say the girl's name is Hadiza also. So we're talking about Hadiza. We've talked about some features about Hadiza. And now, logically, we want to reason or want to explain, like P now is explaining something about Hadiza, about her height and then how beautiful she is, her looks. Also, Q is explaining something about Hadiza, her intelligence, how smart she is. So each of these statements represent logical statements and they are used to explain events. Now, in other words, it could still be defined as the study and analysis of a mathematical proposition as to ascertain the truth value of the proposition. That is also logic. That is another dimension you can view logic. And what they're saying there is just simple mathematical analysis of proposition to know whether they are true or not. The truth value of a proposition is termed T. We will get there when we start solving the example now. If it is true, and F if it is false. Now, let's do a very simple okay, let's see this example. Now, given that 2 plus 3 is equals to 4, you automatically know, based on general mathematics, that this is what? False. Is that not so?
Yes.
The answer is not correct, so it's false. 2 plus 3 is supposed to be 5. So if somebody is telling you that 2 plus 3 is 4, you will argue with the person. Why? Because you know that what the person is saying is what? Wrong. So that wrong in the general term, in mathematics or in logic, call it false. So it is false because it is not true. Opposite of true is false. Opposite of false is true. So the truth value of 2 plus 3 is equals to 4 will give us false, which is F. Now, this is another example, example 2. Now, under T and F, which is truth and false, all you just need to check is if what they are asking you, the condition or the proposition, this is a proposition now. Somebody is proposing something to you. Like if I'm telling you that I might, or I want to travel to the US tomorrow, I'm only proposing that to you. Like I'm kind of telling you. So if you accept it, if it is true, then you know that it's true. But if I'm telling you something that is actually not possible, and I'm telling you it's going to happen tomorrow, you already know that I'm lying. So that's a false. So propositions, if what is being proposed is possible, if it is true, then it falls under the truth statement. If it's not possible, it falls under the false statement. For instance, Lagos is a cosmopolitan state. That is true. Do you know the meaning of that cosmopolitan?
No,
They say that a place is cosmopolitan. You don't know the meaning?
I don't know. If I check.
All right. So from the example or the statement, you should know what it means because I think you live in Lagos now.
Yes, yes. Yeah. I
Mm-hmm.
have a clue of what it means.
Mm-hmm. So if they use it with a city, what they're trying to say is that the place is full of diverse cultures, diverse languages living together. You understand? Like so many
Yes.
people from different places, like nationalities, but living together in a place. That place is cosmopolitan. So let's this Nepal, don't take the light. Now, the truth value of this is true. Of course, you know that Lagos is a cosmopolitan state. That is true. Now, mm, now the truth value table. We have a table that we use for truth value. Can be used to depict or analyze the truth value of any mathematical statement. Yes, we have a table we call the truth table. We will get there. Good. This is the truth table. Find the truth table of P and Q. P and Q. Now let's do some work here before. Let me stop sharing my screen. So we'll go to my whiteboard and write. We have to do some work here. This one is not what to be saying with mouth. We have to do some works. Once you are able to see my white screen or whiteboard, so to say, let me know.
Yeah, I can see it.
Okay, it's showing already. That's fine.
Yes.
Okay. So we have what we call truth table, and it's a very simple idea or logic, let me say. Let me draw a table. Mm, we have the first input, the second input, and the output. That is how it is. The first input, you just have three columns only in just in ordinary truth table, which is just for input, output. Sorry, the first input, the second input, and then uh, the output. I'm going to explain better when we start putting examples. Now, remember what we are trying to look for is the truth value of P and Q. Don't forget P and Q.
Q.
Mhm. They are in capital letter actually. Who is this person? Let me tell the person that I'm in a class, please. Let them not disturb me. Excuse me, please.
Ah,
Okay, so we are combining two things, capital letter P and Q. Now, let's see this. Uh, our input, what we are dealing with, you write them here. And what we are looking for, P and Q, right? You write them.
yes.
Mm, that is what we are looking for. Now, the table is very simple. What we are trying to do is, when a statement is given under P, and that statement is true,
Yes.
and the statement under Q too is true, the combination of both of them will be what? True.
True.
Just like that, she is tall and beautiful and she is intelligent. When we
Yes.
combine the two together, you know that what you later got is true because the first statement and the second statement are both correct. But when you have this one as true and this one as false, under the and condition, eh, the answer will be false. So, under the and condition, the answer is only true when all the propositions are what? True. Each statement represents a proposition. Eh? So, the only condition, no matter how you are choosing, if you like, still go down like this and still say that when P is false and this one is true, you will still get false. The only condition that will make the result of AND logic to be true is when the two propositions you are dealing with, when they are true. Hope you get it.
I don't understand though.
Okay, let's.
You said, but you said that if P is true and Q is true, that means P and Q will be true.
Yes.
Then if P is true and Q is false, then that means that means it will be false.
Let me tell you something now. If I said 3 plus 4 is 7, and I
Mm,
also said 4 plus 3 is 7. Both
seven.
are both are true, right?
True. Yes.
So if I combine them together, I say 3 plus 4 and 4 plus 3 is equal to 7.
Seven.
It's true, right? What if I
Yes.
say 3 plus 4 is 7
Yes.
and 2 plus 3 is 7? What will you say?
False.
You will say no, 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 no. Even though that first one is correct, but that second one, no, 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 no.
Everything is
So
false.
so long one of them, you know what you are doing when you
Okay.
use the word and you tied everything together on a single rope. So they are now functioning as one. So for anything to
Okay.
function as one, both of them must be true.
Mm,
You understand?
yes.
For anything to be functioning as one unit, and which is the work of and is to connect them together to become one. They are now functioning as one thing. So they can only become one thing if the two of them are true. Am I making sense?
Yes.
That is why we said the only way in and condition, or the only condition under and where you can find true as the answer is when the two of them are true. In any other case, the answer will be false.
False.
You get it?
Yes, I understand.
So that is what we are trying to say. Hold on, please. Let me reply this person. Okay, so in real life example, if I say that President Tinubu is the president of Nigeria, and I also said that President Tinubu is the president of United States of America, if I dare use and to join the two of them together, then the answer will be false.
False.
Because truly he is the president of Nigeria, but he's not the president of USA.
Yes.
Mhm. So even if we have something like this, that you know that there is still one more possibility we can have here. That possibility is where the two of them are false. For instance, if I say that Tinubu is the vice chancellor of uh, National Open University and Tinubu is the governor of Ondo State, both of them are false. Is that not so? The answer,
Yes.
the answer will still be false. So just put
Yes.
it in mind that under and what is no, we have many logical gates that you can do it. We have the or, we have the then we have combining them together like the non, the nan. Don't worry, we'll get there. But under basic and logic, the only condition when the answer will fall to be true is when both propositions are true. If any one of them is false, the answer is false. If both of them are false, the answer is false. So that is that on that. Then we'll talk about some objectives of symbolic logic reasoning. But those ones, let's share the screen back now. I don't think we're actually going to be writing anything soon. The rest is to go and be reading. So let's go back to sharing our screen as we now we are done with this logic table. Now, some objectives of symbolic logic reasoning. What are the things this symbolic logic reasoning is trying to open your mind to? Or what does it entail? The first thing is that logical reasoning could be used to ascertain or analyze complicated business argument. In the business world, when you have things that are uncertain, they will employ logic to solve it. You have to use logic and reasoning to solve complex situations or complicated business argument. When the situation in the business field or in the business environment is complicated, logic is involved in solving it. Now, it could be used to decode equivalent, negation, or contradictory propositions. What we are trying to say is that if you make a proposition that is not true, or that is an opposite of what you meant, or that is opposing the original standard, logic or logical reasoning could help in detecting them or in decoding them. Or if you are speaking in negation, negation means negative. We have the positive and the negative. When you are speaking in negation, like now, if I say that Ada goes to school, that is a positive statement. The negation will be Ada did not go, did not, did not. That is negation, not. So Ada did not go to school becomes the negation of Ada goes to school. Now, it could be used to analyze a statement. That's another use or objective of logical, uh, symbolic logic reasoning. Another one is it could be used to form composite statement from simple ones using logical connectives. This is a question in the exam. They say that now there are questions here that normally come out. One of the questions is that they will list three correct ones and put one that is not correct and tell you to fish it out. That one of the following is not an objective of symbolic logical reasoning. They will put one that is not part of it. Then this one alone is a question. They will say that dash could be used to form composite statement from simple ones using logical connectives. It is symbolic logic reasoning that could be used to form composite statement from simple ones using logical connective. Another way they ask it is that symbolic logic reasoning could be used to form composite statement from simple ones using dash. Are you seeing it now? Using logical connectives. So you should know all those statements.
So that question now has two answers.
Which question? No. You see, one logic you should also
To
know.
form composite statement
I,
from simple ones.
I understand. What I meant is that they may cut out anything. You see, this simple statement like this, none can form up to 5 questions from it. They will just be cutting different parts, but it's still the same statement. That is why sometimes when you are doing no exam, if you are very careful, there are some answers you will still meet in other questions. You understand? Your question one may
Okay.
be some of the objectives of symbolic logic reasoning are the following except then they list 3 correct ones and put one. Then your question 57 might be this same statement and it has already the complete statement has already appeared under question one. It used to happen a lot. In fact, funny enough, there are some courses you will do if you are very attentive when you are doing your exam. You meet one single question up to 15 times. There are some bonus courses like that used to happen every year. It used to happen. Some of your courses you will see, and just imagine that you know the answer to that question. This one is not even that they will cut different parts. It's still the same question, but they will just repeat it. The system will repeat it like up to 15 times. That one automatically bonus. You already score 15 marks from that one question. It used to happen, but don't depend on that it will happen. So you have to know that is how you are preparing yourself. So in this regard, this question might come that symbolic logic reasoning could be used
Mhm.
to form composite statement from simple ones using dash, using logical connective. Or they might say that dash could be used to form composite statement from simple ones using logical connective. That is symbolic logic reasoning. One thing is that the reason why some of the students like sitting with each other, which I do not advise because that is cheating, is because your own question that they cut out the beginning, that same question, if you look at your neighbor, if it appear on your neighbor's screen, it may be the end they will cut out, which means the answer you are looking for is on your neighbor's own, while the answer that is missing in your own is on your neighbor's own is on your own. That is another logic in non-exam. But it's not advisable you go and be talking with friends or people sitting around you in the exam. Now, it could be used to ascertain the truth value of a statement. That is the last one. Now, definition of basic logical terms. There are some things you should know in logic. There are some things you should know in logic. They are very common things. Eh? Very common. So let's go over them one by one. Uh, we have 10 minutes more for this unit 1. After the video ends, we'll start another video for unit 2. But I'm recording all the videos. You can visit them anytime. You understand? For now, I will not make them public. I will only collect your email and share it with you directly. Only you will be able to watch it on that channel. So,
Okay.
what are the basic terms you should know when you see them in the exam? You see this one we want to do first is very important. It normally comes out. A statement or proposition is the same thing. You know, I've been talking about proposition all this while, and statement. Even from the
Yes.
beginning, when we started, let P equals so she is tall and beautiful, you say that is a statement. Let Q be the statement. We have been saying it, and even proposition we have been using is the same thing. But what it means is that in the context of logic, it means a declarative sentence. You declare it. It's a sentence that you declare, or an expression of words which are either true or false, but cannot assume
Okay.
both. A statement cannot be at the same time be true and false. It's not possible. So
Okay.
once you see cannot assume both in the definition in the exam, what they're asking you is a statement or a proposition. So if they ask that a dash or proposition in the context of logic is a declarative sentence. Sorry, is a declarative sentence or an expression of words which are either true or false, but cannot assume both. You know that what you feel here is statement. Or what if they say a statement or dash in bracket, is proposition. So two things you have to learn here is that statement can also be called proposition, because in the exam, they may be logical to ask you that a statement is also known as dash. It's also known as what? Proposition.
Position.
You are proposing something, you are saying something now based on proposition. Now, and the other part of this sentence that is very important is that they are declarative sentences that has two destinies, either true or false, but cannot be true and false at the same time. Now, types of statement. Do you understand the definition of statement now?
Yes. I'm also jotting down.
Okay, that is good. So, there are two types of statement actually. For now, for your level, we have the simple and the composite. The composite is also called compound. The simple statement and the compound or composite statement or proposition. So don't forget the two types we have. They say there are dash types of statement. We have two types of statement. That is how they ask the question here. There are dash types of statement. We have two types.
Simple and composite.
And in OBJ, they normally ask the two types of statements are dash and dash. Then they will list different things. You know that what you are looking for as the answer is simple and composite. Sometimes some questions appear in OBJ, they also appear in fill in the gap. So if you are a logical person, you get most of the answers.
So wait, sorry. So I want to ask you, that in that fill in the gap too, there be options?
No. They will just cut it out.
Okay.
Like this statement now, there are dash types of statements. That is all. That is the question. You are the one to know that it is true that we have, and you type the two there. You type TWO there. That is your answer. Now, examples of simple statement. Mr. Alakija is the HOD. They ask this in the exam too, that the following are simple statements except, so they will list some of the things that you have here, then they add one thing that is very long or that is not part of them. You fish it out. So you should know all these things there, they will use 3 out of them in the options and put one that is not there. Mostly they used to use Accra in Nigeria. Mr. Lakija is HOD and I am an undergraduate. That is the 3 they normally use. But it's question bank. Sometimes they may shuffle it. So don't expect that it's only that 3 that you see in the option. So there will be one option that is not a simple statement. Now, the simple statement, Mr. Lakija is the HOD. I am an undergraduate. Rose flower is red. 2 plus 5 is 4. This one is false. You understand? Accra is in Nigeria. This is also false. When you listen to statements, you already start judging whether they are true or false. You know that is the destiny of every statement. Every statement has 2 destinies. They are either true or they are false, but they cannot be both at the same time. Now, the proposition or statement or ascertain from 1 to 5 above are simple ones and can either be true or false. That is true. However, a composite statement is the use of connectives to combine 2 or more simple statements to form just one. Do you see the meaning of composite now? Once you see what are connectives? And, or. You understand? So, if I say that I am an undergraduate and Accra is in Nigeria, that is no longer a simple statement. You understand? Once you see a statement that don't have any connective like this, it's a simple statement. We'll get there. We'll get to the meaning of connectives. But I've mentioned it already. Those are the use of and to connect. You are connecting 2 statements together with them. So once the statement is having up to 2, 3 statements connected using connectives, is a composite statement. So in the exam, when you see a dash statement, is the use of connectives to combine 2 or more simple statements. They used to ask you to, once you see 2 or more simple statements in the exam, what they're asking you is composite statement. Hope you are getting it.
Yes.
Now, example of composite statement. Mr. Alakija is the HOD and I am an undergraduate. This statement is true because the HOD of this material is Mr. Alakija and you yourself that you are studying now, you are an undergraduate. Is that not so?
Exactly.
Another one is
Yes.
Accra is in Nigeria implies that
False.
2 plus 5 is equal to 4. Both are false. You understand? But what do we use to join them together? Implies, you understand, that 2 plus 5 is equal to 4. Now, implies that is what we use to join them together. Now, the truth value of a composite statement is determined by the truth value of each of the simple statements and the way they are connected. What we mean is that the end result, whether this statement will be true, is determined by the individual statement that will connected together.
Together.
So that is what this statement means. And the next we'll be going to is connectives. I've been mentioning them, connectives. We have a lot of them. So we are going to study them. But I don't think we should study connectives now because we have just 1 minute. Now, with this 1 minute, we've talked about the meaning of mathematics, the science of the scientific science of numbers and reasoning or something. Science of numbers, right? That is
Science of numbers and shape.
and shape, sorry. Then logic is also the science of reasoning
Of explaining
or
event.
explaining event.
Explaining event.
So we'll talk about the meaning of statements. We'll talk about types of statements. We have just 2 types. You understand? We'll talk about the truth table, how we can use and in the truth table, and then some objectives of logic. So that is what we've done in this first video.
So you see that we have 2 type of statement. What did you say?
Yes, we have the simple and the composite statement. The composite is also called compound.
Okay.
We've done it now, 2 types of statement. Look at them now. There are 2 types of statement, simple and composite or compound. Composite is also called compound.